Jai Hind, welcome to class of Satellite and Radar Systems. Today we are going to start with Unit 2 and this is lecture 1 of Unit 2. We'll be studying about satellite subsystems in today's lecture. We all know the famous quote that there is birth, there is death, and in between there is maintenance. So yes, today's topic is based on maintenance. When we launch satellite into space, it requires maintenance in its lifetime. So subsystems are basically the systems that will support that maintenance of a satellite. So these are the contents. Satellite subsystems, we will overview, attitude and orbit control systems, telemetry tracking and command control system. These two are just part of subsystems. Broadly, we'll be studying about 6 or 7 subsystems. These two are the basic ones where we are starting our studies with. So these two subsystems we'll be covering in today's lecture. So first of all, why require maintenance and what are subsystems, what is their needs? So we know that maintaining a microwave communication system in orbit in space, it is not a simple problem. Communication satellites are very complex, they are extremely expensive, right? And they're expensive to launch as well. So the cost of satellite and launch are increased by the need to dedicate an Earth station to the monitoring and control of the satellite at a cost of several $1 million per year. When something is launched into space, we need to maintain it, and for maintenance there are instruments that needs to be installed at Earth station, right? And that requires huge amount of money, that is $1 million per year. Now the question is, how do we retrieve back the money? These are earned by the revenues by selling the communication services, like we pay for DTH, we pay for the mobile services, cellular services that we use. So this is how these companies earn their revenues. A typical communication satellite has a lifetime of 10 to 15 years. In the lifetime of 10 to 15 years, it serves us so many applications and we pay for it. That's how the revenue is earned, right? Now the next thing is, in order to support the communication system, satellite must provide a stable platform on which to mount the antennas, be capable of station keeping, provide the required electrical power for the communication system. That is a fixed platform, right? Providing electrical power, providing the temperature, providing the controlled environment required for communication. So there are subsystems, parts like subsystems that will be supporting the existing system. So there are subsystems are needed on satellite to support its primary mission. Primary mission of a communication satellite is to provide communication services. That is, it will receive some signal, it will transmit back some signals. So that is the main task. And what are required to support them? We need batteries, we need solar power, or we need energy, right? We need some systems that will maintain the satellite in its orbit. So there are several things associated. So this picture shows a typical satellite. It has the bus, it has the payload separation. Bus is the carrier and payload is the actual communication part of the satellite, the actual technical part of the satellite, right? So a subsystem that must exist in all satellites is the communication subsystem that enables the spacecraft to communicate with the ground stations that control the satellite and to deliver the data that the mission requires, right? So we can see in this picture, this drum-like structure is the satellite. It has various antennas mounted over it, the GPS antenna, the X-band antenna, S-band antenna. These are the solar panels. There are solar cells mounted on it, so it continuously gains energy from sun to support the working of the satellite. Although it has some batteries as well in case of solar eclipse or any other emergency situation, it may switch on its power, it may switch its power to the batteries. It has cameras, suppose this is used for surveillance or weather monitoring, so cameras are required. So this is a very basic picture, and we tried to incorporate as much as things we could show it here. A reference is mentioned here. So if we divide a satellite subsystem, it is categorized into 3 parts: the space segment, the user segment, and the control segment. The space segment lies in the satellite, so it is the satellite itself, right? The picture we have, this complete part, it could be considered as the space segment. But the collective work requires a user segment as well, a control segment as well. So the user segment will include all the applications and the services that we use, right, and the equipments associated with it. Whereas maintenance and controlling of all this will be in hands of the Earth station. So we have various sensors which are mounted on satellite, various radio communication equipments that will be receiving signals from there, various channels that will be transmitting the command signals over satellite from the control station or the Earth station. We require human power here to monitor and control these things. So collectively, these 3 segments, the users, this space segment, the user segment, and the control segment, is collectively called as satellite subsystem. It consists of the satellite subsystem. So space segment consists of all satellites and associated equipments. The user segment, it consists of all the applications and necessary equipments that we use, right? Personal facilities and equipments, right? Satellite controller segment consists of the personal facilities and equipment, and user segment consists of all the individuals and groups who use and benefit from the data. Like we are the users, so we come under user segment, and we use various equipments also. Those also comes under the segment, right? So let's start with the first subsystem, that is AOCS, Attitude and Orbit Control Subsystem. First of all, we need to understand what is attitude control and what is orbit control. Whenever we are talking about placing a satellite in space, first thing, it has to be in its exact position for the desired time, right? It should be rotating, the orientation towards Earth must be fixed, because the role of that satellite would be, suppose it is it is used in military for surveillance, it would be looking to particular place, so its orientation should not get dismantled, right? It should look into particular space, particular area for 24/7, right? Another thing, it should not lose its orbit. If it is following a particular path, then only covering that area will be done in a particular time period with particular velocity. If one thing gets dismantled, the whole process falls down. So maintaining the orientation and maintaining the path, these are the 2 things. Maintaining the orientation comes under attitude control, and maintaining the path, that is exact orbital path, elliptical path, comes under orbit control subsystem. So AOCS consists of rocket motors. Whenever there is little movement in the motion, that could be because of Earth's gravitational pull or gravitational pull of other heavenly bodies, we can get back the satellite into exact orientation with the help of some energy applied. How do we apply those energy? With the help of some thrusters, rocket jets, right, small jets. So these are already mounted in the satellite, and we do control them manually from Earth station, right? So attitude control subsystem takes care of the orientation of the satellite. Now let's talk about orientation first, then we'll be talking about orbit control, right? In orientation, for orientation management, for orientation control, these are the 2 basic categories of satellite we can use, that is spinners and the 3-axis stabilization method. Spinning the satellite is a method, and the satellite that uses this method are called as spinners. 3-axis method is a method, and the satellite that uses are called as 3-axis stabilized satellites. With the help of pictures, I'll try to show them. So this is a spinner satellite. It looks like a drum. It has solar cells mounted all over its body, right? Here in 3-axis stabilized, the solar panels are like wings, When we launch the satellite, these wings are closed, and when the satellite goes into its space, then the wings are open. So these solar panels or these solar cells, they do obtain energy from sun for the proper functioning of the satellite. Now the thing is, how do spinners maintain their orientation? How do 3-axis stabilizers maintain their orientation? One by one we'll study. This picture of Intelsat 4, right? This picture of Intelsat 5. So what are the forces? This picture shows shows 3 dimensions for the 3-axis stabilized. We have yaw, pitch and roll. So here we'll study about this yaw, pitch and roll in 3-axis. Let's start with spinner first. Spinner, what we do, we keep spinning the satellite so that because of the momentum, it is somewhat prevented from changing its orientation. Orientation is maintained by providing, suppose you keep a body idle, it has greater tendency of tilting. If that body is rotating continuously, that will have a momentum of itself and it will resist any kind of change. So in spinning, what we do, the satellite is rotated at 30 to 100 rotations per minute in order to produce a force which is gyroscopic type, right? So this will maintain the satellite in its exact orientation. Now the question is, due to the spin, the axis gets stabilized and satellite will point in the same direction. Now the question is, if the satellite has a camera and it should point to a particular position, how do we maintain that thing? So for that we use a D-spin system, so that if the satellite rotates clockwise, the D-spin antenna will be anti-clockwise, so that the rotation is cancelled out, and the antenna must point out in the direction which it is meant to point, right? So D-spin system we use here, right? D-spin. Here the communication subsystem is placed on top of the drum. Electrical motor drives this communication system, and direction of this motor will be opposite to the rotation of the satellite body, so that antennas point towards the earth, and this operation is called as T-spin, right? In 3-axis stabilized method, we stabilize the satellite by the help of momentum wheels, right? So in this 3-axis method, we have this, we can see the forces in 3 directions, yaw, pitch and roll. Here the roll axis is considered in the direction in which satellite moves in the orbital plane. Yaw is the direction towards earth and pitch is considered perpendicular to the orbital plane. This is perpendicular to the orbital plane. Yaw is towards the earth, to earth center, and your roll is in the direction in which satellite moves in the orbital plane, in the direction of the satellite movement. So these 3 forces, with this picture is easier to understand, I guess. So wherever it gets tilted in any of the, all 3 axes can be maintained. We have small rocket jets mounted, and we can operate them for earth station, right? So in 3-axis method, we have XR, YR, ZR. These shows the direction in which the 3 axes define the altitude of the satellite, right? Now X, Y, Z are another set of Cartesian axes. This set of 3 axes provides the information about orientation of the satellite with respect to reference axis. If there is change in altitude of the satellite, then the angles between the respective axes will be changed, right? So in this method, what we use, we have 2 sets of gas jets. The first jet will be operated for some period of time when there is a requirement of satellite's motion in a particular axis direction, right? When we require satellite's motion in a particular axis direction, we'll ignite the first gas jet, and the second gas jet will be operated for some period of time when the satellite reaches the desired position. So these are used at the time of launch, right? The second gas jet will stop the motion of the satellite in that axis direction. So to initiate tilting towards one and to stop it, first gas jet to initiate it, second gas jet to stop it, to counter it. So this is how it works. Orbit control system, subsystem, it is useful in order to bring the satellite in its correct orbit. So we have spoken about a attitude control, right, maintaining the height and orientation. Now orbit control, that maintaining the path, right. For this it works in collaboration with TTC&M. The second subsystem that we are going to study, telemetry tracking and command control system, that works in collaboration with attitude with orbit control system. If there is some change in the orbit, the command signal must go from Earth station, and for sending that command signal, my TTC&M comes into existence. So TTC&M subsystem, it is present at Earth station. It monitors the position of the satellite. If there is any change in satellite orbit, then it sends a signal regarding the correction. Error observed, correction signal sent, right? That's how it works. In this way, AO system takes care of the satellite position in the right orbit and at right altitude during the entire lifespan of the satellite in space. So let's start with the second subsystem, that is my TTC&M. So along with TTC&M, the orbit control will be studied. In telemetry tracking, commanding and monitoring system, this is present in both the satellite and the Earth station. Example I will take, sensors are present at satellite to check its temperature, its health of the satellite, but the signal is sent from there using some communication module, and there is part of the communication module installed at Earth station that will receive that signal, and the correction signal will also go from here. So part is at satellite and part is at Earth station, right. Therefore, TTC&M subsystem is very much necessary for any communication satellite in order to operate it successfully. Now, it is the responsibility of the satellite operator in order to control the satellite in its lifetime. So, after placing it in the proper orbit, this can be done with the help of TTC&M. Once a satellite is placed, now maintenance, right. So, for maintenance, TTC&M is very important thing. First part is telemetry and monitoring system, second is tracking subsystem, and third is commanding subsystem. Let's study all three in detail. With the help of this picture, it's clear. This is the satellite, right. This shows uplink, this shows downlink, right. So for uplink we use transmitting antenna, for downlink we use receiving antenna. Telemetry tracking and command system, we have tried to show it here. This is the telemetry receiver. Tele means far, metry means transmission of signals to far distance, right. Receives signal, processes the signal, right. Ephemeris data, the redundant data, and we use some redundant data, we do the comparison, right. We have a controller here. The controlling signal must be sent through the transmitting antenna with the help of telecommand transmitter. This tracking system keeps tracking all of this process, right. So we receive something, we study it, analyze it, and according to it we send the control signal, that is through uplink. So this is how it works. Telemetry means measurement at a distance, generation of electrical signal which is proportional to the quantity to be measured, encoding the electrical signal, these are the steps which occurs, transmitting this code to a far distance. See, the basics of communications are obvious: modulation, multiplexing, error control. These are a separate field which we study in analog communication system, digital communication system, computer networks. So that is, we consider that is there. We are basically dealing with the focusing on satellite part, right. So telemetry subsystem present in the satellite performs mainly two functions: receiving the data from the sensor, transmitting the telemetry, receives, transmits, right, receiving data from sensor, transmitting data from Earth station to satellite. Satellites have quite a few sensors to monitor different parameters: pressure, temperature, status, the health of the satellite. That should be good, right? Various subsystems. In general, the telemetry data is transmitted as FSK or PSK. That is the point to be remembered, right? Of course, we do modulation. Wireless communication comes here. So we are using shift keying techniques. FSK and PSK are the famous ones, right? They have their own advantages, right? So on air, my data is an analog signal. Here my messages in 10 format, and it modulates a high frequency sinusoid. So we use shift keying techniques, FSK and PSK. Telemetry subsystem is a remote control system. It sends monitoring data from satellite to earth station. Generally, the telemetry signals carry the information related to altitude, environment and satellite, right? Tracking subsystem. Tracking subsystem, it is useful to know the position of the satellite and its current orbit, right? It's required. SCC is Satellite Control Center. It monitors the working and status of the space segment subsystems with the help of telemetry downlink, and it controls those subsystems using command uplink. So the role of the tracking subsystem is monitoring the working and status of space segment subsystem with the help of telemetry downlink, and controlling the subsystem. That is, it is a connecting link between telemetry and the command system, right? We know that tracking subsystem is also present in an earth station. So it mainly focuses on range and look angles of the satellite, whether the range of the satellite is okay, correct, whether the look angles, azimuthal and elevation angle are accurate as per the requirement. For example, change in orbital position of the satellite can be identified by using the data obtained from the velocity and acceleration. If there is a minute change in velocity and acceleration, that means there have been change in the distance, there have been change in the orientation, there have been change in the track of the satellite. So by observing these errors, these changes, we can easily get to know that there has occurred some change, right? The tracking subsystem that is present in earth station, it keeps tracking of satellite. When it is released from last stage of launch vehicle, it performs the function like locating the satellite in initial orbit and transfer orbit. What does it mean? Tracking subsystem, it is present in earth station, but it always keeps a track of the satellite. When it is last stage of the launching, the actual satellite comes out of the envelope, right? So at that time, tracking system performs the functions like locating the satellite in initial orbit and then to transfer orbit. If we remember that how satellites are launched into space, we initially we use slow orbit raising, or we use GTO, geostationary transfer orbits, like the example of geostationary transfer. We have seen the example of geostationary satellites. There are various ways by which we can launch it into space. So they are never directly launched into space. There is a way to launch them directly into its exact orbit, but there are stages in between involved, right? In placing the satellite into initial orbit, then placing the satellite into transfer orbit, then into exact orbit, and even the complete motor, the rocket system, that doesn't goes up to the exact orbit. In the final stage, the satellite comes out of it. So at that time, tracking subsystem, it performs functions like locating the satellite in initial orbit and in the transfer orbit. So this is the task of tracking subsystem. And now what does commanding system does? Commanding subsystem is necessary to in order to launch the satellite in an orbit and it's working in that orbit. In order to launch the satellite in the orbit and working of the satellite in that orbit. The subsystem adjusts the altitude and orbit of the satellite whenever there is deviation in those values, right? Whenever there is deviation in the altitude or the orbit, path, right? Those values are observed, are received, analyzed, calculated, and the correction values are sent, and that is done. So commanding system, it also controls the communication subsystem. This commanding subsystem, it is responsible for turning on off of other subsystem. This is one of the very important tasks, turning on off other subsystems present in satellite based on data getting from. How it works, they all work in collaboration. My like the computer CPU, it cannot work until I give it some input, and the processing will occur there, and it needs some output devices as well. So this is how the commanding system works. When the control system studies, analyzes, and sends the system, commanding system will come into existence, receiving, transmitting, right? It is responsible for turning on off of other subsystems present in the satellite based on the data getting from telemetry and tracking subsystems. In general, control codes are converted into command words. Control system generates changes in angle might be calculated in electrical terms. Then those electrical pulses are to be converted into command words, because then according to that electrical value, maybe voltage value, we have to shift back the angle. So the control codes are again converted back into command words. So all this occurs inside. These command words are used to send in the form of TDM frame. Usually time division multiplexing is used in case of satellite communication. We do send frames of data, right? So packet tracing, it is another concept. In TDM we have actual data, the source, the destination, some preamble bits, some redundant bits. So these usually go in time division multiplexing frames to efficiently utilize the communication channel, right? Whenever we study any communication channel, any communication system, the two main resources, power and bandwidth, that has to be taken care of. So for efficient utilization of the bandwidth, for efficient utilization of power, what do we use? So to efficiently utilize a communication system, we do use multiplexing techniques, and TDM has its advantage over FDM. So in satellite communication we use TDM. Initially the validity of command words is checked in the satellite. After this, command words can be sent back to Earth station. So here these command words are checked once again. These are the steps, right? If the Earth station also receives the same command word, then it sends and execute instruction to satellite, so it executes that command. So functionality wise, telemetry subsystem and commanding subsystem are opposite, since the first one transmits the satellite's information to Earth station and the second one receives command signal, but they work in collaboration, right? So these are the references. That's it for today. Thank you.